Very good afternoon to one and all present here. Thank you so much for coming. I welcome you to the Ally Project, an event which we are representing enabling engineering, the most creative and innovative student-led group in Northeastern University. They are using engineering to build devices for disability. And their work is astonishing. And I'm very happy to present the mentor of the group, Prof.Waleed Meleis, who's also the graduate dean for academic dean for graduate studies. Thank you all for being here. I give it to Professor Waleed Meleis to take over.
Oh, well, thank you for that kind introduction. Had I known you were going to say that, I would have come a long time ago. It's saying I'm muted. I'm assuming this is working. This is good. Okay. So hello. Thanks for this invitation. I'm very interested to learn more about this group. This group seems to have a great mission and great activities. As you heard, my name is Waleed Meleis, faculty advisor for NU Enabling Engineering. I'm joined today by Pragnya, who's a member of the management team for Enabling Engineering, and Aditi, who is our program assistant. So I'll say more about their roles as we go. I'll start by describing the big picture. So Enabling Engineering is an innovative group. It does some very interesting, challenging things, and it has kind of a broad scope. So to explain to you what it's about, I'm going to take you back to the beginning, how it was formed. So the history is, for many years, I taught design projects, the senior design classes in the College of Engineering. And we call those capstone design. And one year, now look, almost 10 years ago exactly, I had a particular project that was trying to build a feeding device for an individual who didn't have use of their arms. The idea was that an attendant would feed her, and wouldn't it be great if they could have a little bit more independence to feed themselves. So this group developed the system, got it working, went down to a nursing home in Fall River, Massachusetts, tested it out, and it worked on this person. We took videos, and we ended up winning first prize in my department's design competition. So this was great. You know, it makes the group feel good that they won this prize. What happened then is the university created some press around this, and it ended up getting featured by CNN, Engadget, Forbes, PC World. And that was really exciting. You know, we're not used to being in the mainstream press. People, I'd be riding in a taxi in New York City, and they'd have those little TVs in the back of the taxi running ads, and they would sort of run a little video clip about this project. It was like really, it was otherworldly a little bit. But then what happened next was really amazing. We started getting letters from all over the world, from people who had seen the media saying, this is the most incredible thing. I want one of these. It's so great that you're doing this. Keep doing it. I'm projecting 3 pictures of the prototype. You can see one of the student members in front of the eye tracking interface. He would look at a particular colored square, and that would indicate which bowl he wanted to eat from. And then there's a picture of a spoon that would then go get the right food and feed it to him. So there are a close-up of the bowls, and then a close-up of some of the equipment. So this really struck me that this project had been so successful and had really gotten so much attention. And I started to reflect on what was it about this project that really allowed it to work so well. And here are some of the characteristics that we extracted from this. We saw that there was a clear unmet need from an end user. There was a dedicated group of students, and they had time to invest in the project. There was contact with a partner institution. We weren't just sitting in the lab thinking, we were working with a partner. The students had support of a management support, administrative support from their advisor and from the department. There was funding available, lab space. So enabling engineering kind of was born out of this. It began as an effort to replicate the conditions that supported the success of iCraft. Because in most university projects, these conditions aren't all there. There might be 1 or 2, but maybe not all of them. Okay. So our mission has become to build low-cost devices that improve the lives of older adults and individuals with physical or cognitive differences. We help family members, we help care professionals, teachers, we are part of our mission that we've learned over the years is that empowering individuals is really important. We don't want to only force people with disabilities and differences to be dependent on somebody else. People want to feel empowered and independent. So we try to do that. And even more broadly, our goal is to, this is a university. We're not just building devices. We're, many of you are products. We want to be educated, to be more aware of disabilities as you go on in your lives. You'll be teachers, scientists, educators, engineers, clinicians. We're trying to educate the next group, the next generation to be more aware of disabilities in their work. So I'll turn now next level down to what the group actually does. We go into the community. We have lots of contacts in the Boston area, in Massachusetts, and actually around the world to learn about the needs of individuals with disabilities. We work with them to develop project ideas. We work with clients, families, clinicians, teachers, research, really anybody who has an idea. We bring these ideas back to campus and we build project teams around those. We get interested students, and then we try to give the students everything they need to succeed. What do we need? I've already told you, right? They need lab space, funding, mentorship, time. We support the projects for as long as it takes to get a prototype built. And then at the end, ideally, we would pursue IP protection, marketing, and business. In reality, that's a work in progress. So what's interesting about enabling engineering, and one thing that I really feel has contributed to success, is that it's kind of an umbrella over a whole bunch of different activities. It's not just a research project. It's not just a student group. It's a volunteer group where students volunteer their time, usually in the evenings. In my home department, the electrical computer engineering department, it's a technical elective, so you can take a course, get technical credit for one semester. We have been a service learning partner, which means that students who have a community service requirement, they can spend a semester working on a project, and that will count as community service for them. We infuse engineering capstone projects with enabling engineering support. So if a capstone design group wants to work on a project with related to disabilities, we'll help them. Maybe we'll connect them with a client. We'll give them product ideas, let them use our tools, contribute funding. And finally, we're an employer of graduate students and undergraduate students who provide technical support for technical and administrative support for enabling engineering projects. We are really open to the community. So we work with really anybody who wants to work with us. If anybody, a faculty member or student on campus, they have a project in mind, we'll just talk to them and we'll say, oh yeah, you're looking for somebody like this. We have 3D printers. We know somebody who has this disability. We know a clinician who's an expert on this. We're really a relationship organization. We maintain these relationships and make connections to support our goals. Another way of looking at this is that enabling engineers are many different kinds of people in different roles. They include students in the evening meetings, the volunteers, students in the technical elective, students taking capstone design. We have these students, this is not happening right now, university scholars volunteering with the group. We have professional design mentors, faculty collaborators, partner organizations. We have experts on disabilities coming in weekly when we teach classes to lecture on disabilities. We are overseen by undergraduate management team members. Ragnar is one of those. The group, as I'll say more about in a second, is quite large and quite complex. So in the old days, I personally supervised every group. So that didn't work. Then we built up this hierarchical structure. So the undergrads organize and manage themselves. So we usually have 3 to 5 management team members who meet with student groups each week and handle other administrative aspects. I'll say more about that. We hire graduate program and engineering assistants. It often happens that undergrads get stuck. There may be something they want to be able to do and they can't. Most typically 3D printing, mechanical design, app design, and hardware design. So we maintain lists mostly of graduate students in the College of Engineering who are interested in helping with these projects. And we hire them hourly, and they'll just help support the undergrads. And finally, part of our enabling engineering community, the clients themselves, their families, their caregivers, and their teachers. We consider everyone to be part of our mission. I've said that we're kind of a relationship-focused organization, and part of that are our community partners. I've loved getting involved with enabling engineering. I've been in Northeastern for a very long time, much longer than I've been doing enabling engineering, without knowing about all the interesting partners right around campus. Some of them literally blocks away that I didn't know were here. So this is just a small subset of the partners we have engaged with over the years. And some of them we do project after project with. They really see connecting with the university, particularly a neighbor that's so close, as part of their mission. So let me say a little bit about let me go like one more level down in detail. The group is organized like this. We have a collection of anywhere from 10 to 30 projects going on at any time. May have 2, 3, 4, 5 students in each group. There's a project leader. We have these undergrad management team members that I mentioned who meet with projects every week, get project updates, and the goal of what they do there is to solve problems. There are so many problems you could possibly have: parts, equipment, expertise, missing members. We have a beautiful lab where everybody meets. And on top of all that, we have funding for one part-time co-op student. Sorry, one full-time co-op. It used to be a part-time co-op student, but it was too much work. So now we have a full-time, and Aditi is right now our full-time co-op member, co-op student. And she sort of represents me in keeping an eye on the lab, the groups, the students, the clients, and generally, keeping things moving. A very important role of the management team and our program assistant is to manage our policies and make sure they're followed, and to manage communication with our clients. We have a very organized process of developing and kicking off projects. So if you want to work on a project, you don't just start working on it. You have to create a project plan, a schedule, a parts list. You have to connect with your client. It has to be shown to a client. A client has to sign some paperwork saying they understand, yes, this is the plan. So by the time a project starts and we get all these signatures, the students, the management team, and the client are all on the same page, so that nobody feels like what they were hoping would happen hasn't happened. So the program assistant really oversees that process and make sure that those policies are being followed. And the program assistant also takes care of our beautiful lab, buying parts, keeping it organized, and most importantly, making sure everybody is safe. Let me pause there. Are there any questions or comments so far? I was planning on spending the rest of it. Go ahead. If you like.
Okay, so out of curiosity, in the process of developing the device, how much does the client have say in the product?
So a core part of how we operate is that we are responding to the need that's been identified by a client or that's been confirmed by a client. So part of the process of starting a project is, there's a part of the box that says, what is the need you're addressing? Who is your client? Have you met with them? So I'll just emphasize how important the client is in part of the process. The wrong way to go about this is for students to give an idea and then go looking for a client. And look, this is what you need. So we are avoiding that approach. So the question is, what involvement does the client have? Often the idea comes from the client, so it's 100%. Or if it's some sort of brainstorming, each side is sort of contributing some ideas. But if the client isn't satisfied with the plan, there really isn't a project to pursue.
One of the philosophies that I really believe in is that it should be with the individual as opposed to for them.
Yeah, so that exactly matches. And in fact, we've tried to take that another step further. We don't want to think of the group as being on one side and the clients over there. We actually want people with disabilities to be working side by side. Of course, our people with disabilities are all around us, and our students have disabilities. So but we've also sought out individuals. I'm thinking about a particular. We worked with a high school where they would send us high school kids with disabilities to actually join project groups to work on projects for other people. So bringing minors on campus is incredibly complex. That was actually one of the reasons we hired a program assistant to begin with, because it was too much. But it was incredibly rewarding to actually make that happen. You're welcome. Before I switch to the next chapter, any other discussion about the mission of the group or its structure? All right, I thought I'd spend some time now talking about some specific projects. So this is blind navigation map. This is a collaboration with the Museum of Fine Arts around the corner. We was very delighted to find out that the MFA is deeply committed to supporting individuals with disabilities and making its materials available to people regardless of their background or their abilities. So they've really been a great partner. If you've been over there, you'll know the MFA is very large and very complex. I still cannot find my way around. And so they asked us to create wayfinding tools for blind individuals. And the solution that was proposed that we're working on is to create a portable tactile map. We're basically 3D printing it. So I'm showing you here on the left is the MFA map, which is very detailed and complex. And on the right is how a rough, this is the first prototype of a tactile map where you can see the different areas the rooms are basically outlined with bumps so that one can sort of feel the shapes of the rooms and the structure of the overall space. This is just the beginning, and the pandemic has intervened, so we haven't done a lot of testing with this, but we are getting this group going again and hoping to evaluate this and improve it. Who can tell me? Who's seen it recently?
And they carry it around.
So I believe the plan was for this to be mounted. This was not a carry around idea.
Somebody stand at the wall. But when you're going to have you guys worked with blind people?
So this was interrupted by the pandemic. So I think
Okay, I would love to help. I mean, one of the things is also how does a blind person find the map to use it?
Yeah.
I think they first wanted us to first see if we could visualize the map at all of the different that we had, and then the next stages were implementing on how they would implement this actually throughout the museum, and then of course bringing and test it out.
That's awesome. There's a lighthouse for the blind in San Francisco that literally has an entire software and a tactile printer in which they have refined the process of being able to 3D print maps of anything.
Oh my God, there we go. So that's fantastic. So DT, you can help us remember to
Yeah.
make this connection.
On this example that you have, color is indicative of obviously spaces. Are you going to have feel rather than color?
Yeah, I think this is just more to see because we're some pieces, and so I think there's kind of see that
I think these are just different materials, right? I think they're just different materials.
I would love to help. I have a lot of ideas.
Oh yeah, we will definitely.
It's nice to have a little expert.
Just by using.
This is a project called Pedaling Music. This is another one of our favorite collaboration with one of our favorite partners, which is Carter School. The Carter School is like a stone's throw from here, tucked in next to the orange line. It's a Boston public school. There are many Boston public schools that serve individuals with disabilities. It is the one school in the Boston system that serves the 10% of students with the most severe disabilities. So often the kids are nonverbal and non-mobile. So we've done a lot of projects with them, and this is part of a kind of a theme of trying to give kids a reason, give them the feeling that they are affecting their environment. So they're doing something that lights something up or make a noise, or just so they can have some interaction, because many of them feel kind of cut off because of their challenges. So this was basically an exercise bike that plays music as you pedal and stops when you stop pedaling. So the idea is to help them be in better shape and improve their dexterity. So I'm showing a picture on the right of the original device, the restorator. And on the left, I think we're seeing some of the electronics attached. Oh. Zooming in, there are some electronics there that senses the motion of the pedal and then powers something like, I think it was like an iPod or something like that. For the same client, there was a desire to create devices to let students feel like they're controlling their environment. The kids there love puzzles, and we wanted to give some way for the kids to have kind of more feedback from successfully solving a puzzle. So I'm showing here on the right, kind of the core puzzle. It's about 1 foot wide, 1 foot high, with 3 cutout shapes. And they picked an underwater theme, a fish, a turtle, and a sea star that are missing. A lot of work went into kind of figuring out the theme, figuring out the sizes, and figuring out the materials. And on the left, you can see a child holding one of the pieces and kind of putting it in. When you 3D print things, the tolerances are so precise that it's very easy to put a piece in and not be able to get it out. So our students had to work hard to get a little handle attached to the puzzle piece so that a child could have the dexterity to put it in. And they had to kind of make things big enough so that it would jiggle a little bit, so that it would, there was some tolerance to putting it in. But this was a completely finished project that was delivered to the Carter School and being used today. What's interesting about projects like this is that if we were going to build another one, it really wouldn't be that hard. We have the plan, we could 3D print the base pieces, but really the design process and the close connection with the client took a really long time. There were so many versions of this to get every detail exactly right. Are you working on Sensory Wall? I think you've worked on. Do you want to introduce this one?
Oh, okay, yeah. So I've managed Sensory Wall. Sensory Wall works with this company called Lifespan, and they're making like a sensory wall for adults rather than usually a lot of our clients for adults, those with sensory damage. So it's a wall with different objects, like things with different textures that make them auditory. Tactile. The idea is that they can interact. Their interaction. They iterate the project depending on the needs. We have like multiple needs boards, so it's not just one. It's like different components that all come together and make one big wall.
So we're showing, to describe it, we're showing 3 pictures of different iterations, different versions of this. In each case, could be ropes, chains, what's that? Some sort of carpet that looks like grass, things that spin, ropes that go up and down. Anything else to add? What's the status of this project?
They're close.
Okay, I'm glad to see that, hear that. I see it sitting in the lab, so I'm glad to hear that.
So with a project like this, how
it also forces the groups to kind of learn how to work with non-technical clients because we realize that a lot of times either if we're not working with individual disability, we're working with people because they might have trouble describing specifically or understanding what, you know. So it's a lot of iteration. You'll find a lot of these projects take a lot longer than you might think because it's a back and forth process. Getting to the client, setting up in person, and test that, reaction and making sure that we're staying on track. And because, luckily, like this is all volunteer, everything that gives the client people to feel comfortable to ask them. A lot of times it's hard to get into something and you have a hard to continue the process if you're not happy with the as we establish these relationships and especially because there are a lot of times that people that we work with before, they feel really comfortable asking us for exactly the thing. So I think it's strengthened like culture, and kind of giving them the space to actually demand for a product that they deserve. It also gives like the students an idea of time and coming up with an idea of what they want and forcing it on. It's kind of off that idea of time. Product for them or make it with them.
Do you think that's different than any other design process? Because presumably any design process would incorporate stakeholder feedback and get prototypes and everything like that. But you're implying that it's more in-depth or
I think we just try to strive to be as connected as possible. A lot of times we do themselves as people. So, and especially if we're working with private populations, like families, it can be really hard sometimes to walk them through it. A lot of times when you're working with industry, it's like at least like for co-op, we're working with like entities that are asking for it. And a lot of times here, parents don't really understand the technical aspects, so sometimes we have that challenge of like we have to take that extra step to make sure like we're translating their needs because we might not know what they're asking for. Right. Like when you're working in the same field, it's easy for me to ask what I want from you. I want something that just $10,000, but because it's not something that we're interacting with that kind of thing, where we have made a product before, we have to spend that extra time asking extra questions that they might not even think either.
and have you been able to codify that process? It seems like it's something that you're going to have to do for most of your projects.
Yeah, so that's why we have this extra layer of efficiency. So we kind of do a lot with my communication. When we're bringing especially for younger undergraduate students, they haven't really experienced design process maybe in like a setting or, in this case, we're actually working with a client. So that's where we step in. So we are monitoring client communications, we're meeting with the group so we can identify gaps. So we have experience because we do client communication for each of the groups. So we have we are the expertise in that. We're helping the groups make sure that they're creating like an extended design and they're making sure that they're addressing the needs of the client people maybe doing that. Yeah.
Do you feel like there are processes that you have established in the group that maybe the larger community can learn from?
Yeah, so what we do, something that I think, again, kind of going back to that idea that we're dealing with like an international, like technical, non-technical, they might not have ever asked for like a product before and how to design it and what they need from it. So what we do is each semester we send out a project plan. Especially if these projects run for years, and so each semester we have the groups sit down and identify the exact goals that they want to achieve for that semester. So design deliverables, like we're gonna put the lights on, or we're gonna get this to move, or that to move, so that we're actually able to give them something people listening for, and then that way they can also kind of follow. So as we're doing the semester, we're actually drawing the going, like, oh yeah, this to work, oh yeah, that to work. They know exactly where we're going the day one of each semester, so it gives them kind of like a roadmap to go on. So we have that process in place. We have client communication requirements, so they're talking to clients at least once every 2 to 3 weeks. Some clients are talking to their groups on weekly or like bi-weekly or whatever they work. And some clients, their groups are friends with their clients, so they're on their own phones, like chatting. And so we have these like requirements in place so that students are communicating with them. And then we have like the in-person meetings that we schedule for the local clients, or the Zoom calls where we're showing them end of semester projects and mid-semester then we have to fine tune them depending on the client. So for the more technical clients, sometimes their communication requirements are different than those who are non-technical, and they require more information and more kind of like visualization of the actual project rather than just maybe like an email with photos. So it's a base process that we have. That we
And so the question also, you're wondering, can this be exported to other groups? It sort of grew organically out of our experiences. So I'd be very skeptical about just exporting it. But in forums like this, it's great to just sort of explain what we do and see if some piece can be shared.
Writing something about best practice,
Yeah.
because this design process might be a little bit different than the standard engineering design process that you've developed best practice organically over the years. Being able to write that up and say, here is our experience, and at least people can start at a level that would allow them to incorporate. Sorry, I think that would be important.
I can speak from experience and like from the blind community. There are some technologies out there that were produced and designed. Clearly, they never asked the blind person along the way. And so like the blind community is like, what am I gonna do? This higher tech came. Then nobody really buys it.
Yeah.
Like so like these practices are fantastic to share. Like there's multiple devices I can refer to that clearly nobody like consulted with a blind person, but they were like, a blind person is gonna be our consumer.
We're with you. That makes perfect sense. I like the idea of writing things up and communicating more broadly.
I think it's a nice goal for somebody in your position, like how can we capture all this knowledge that we now have and provide best practice?
I think a lot of this is very good for us too. When in our engineering field, at least the design process I've interacted with, at work or at school, is different. Like your ed client, it's a different process. And so now when you're working with people, they might not even know what they're asking for. It's like this additional process where it's like you have to put in the work to kind of guide them and to explain what they want.
Yeah, they don't know what they don't know.
Yeah, exactly.
But they know what they want, like they have an idea of what would work for them.
Exactly. So yeah, I agree. Very much on that.
Other discussion?
Do you have more clients that you have students or to do projects for, or how do you balance? Is there a wait list for?
I can go ahead. I mean, we have a very large number of, we maintain databases of project ideas and clients. And the pandemic has been very hard on us, like for everyone. So students really have kind of drifted away. But at our peak, we would send out announcements just to the College of Engineering, and we'd get 300-400 responses from students. So available projects was much smaller than.
I feel like I can provide you 10 projects. So that would cost me.
Yeah, that's fantastic. But I would say now there's been a reverse. I mean, now I'd say we're looking for students are not coming back to these sorts of volunteer activities quite as enthusiastically as they were before. So Mona, I'm looking forward to seeing those 10 projects. I'm gonna write that down. So here's let's see, just a few more minutes. Another one of our favorite clients is Max Plansky, who has cerebral palsy. And he is very closely, he's kind of a celebrity on campus. He's been very connected to the basketball team and is around all the time. We've known him basically for 10 years. So we basically all throughout his childhood, now he's a young man. So at different stages, he's had different interests that we've tried to support. So at this stage, he was very interested in video games, and he was really wanted more independence in playing video games. So this has been an ongoing project to allow him to control an Xbox controller using his head switches. So Sandra, you asked about when our project's finished. This project is one that never finishes. And the reason, so here's a picture of Max on the left with 2 of our students next to him, and he's trying out the controller. And another time at one of our design presentations, we have a student group holding some of the equipment. The students love this project, and they love working with Max and his family so much, they really don't feel any incentive to finish. So I kind of figured out, It's been years. No, 3, 4. It's been years. So they sort of feel like that this project is like a little student group in and of itself. Students come, students go. Max is perfectly happy. They keep giving him new versions. So what really happens is the project keeps going until the students graduate, and they don't want to stop because they're really loving it. So I'm trying to get away from this. I feel like maybe, well, we have donors, and we want to be able to report success and completion, and we need to be able to sort of wrap things up and say that things are finished. So that's the I didn't mention.
Max just needs to say it's good on all the prototypes.
Sorry, could you repeat that?
Max just needs to
Max,
say
yeah.
that it's all good.
Yeah.
On all the prototypes, that they're all
Yeah.
done.
Another partner is the Puppet Showplace Theater, right down Route 9, right down Huntington. This is another organization. It's a classic puppet theater. If you haven't been there, it's a really nice place. But they're very committed to supporting individuals with disabilities, and they really want to make everything they do available to people with various disabilities, both watching, but also being a puppeteer. So this was a project to adapt a rod puppet to allow an individual with a hand disability to control it. So here's a picture on the right of a puppet, kind of like a hand puppet. And on the left, there is a device, 3D printed device that has a white tube sticking up, 2 arms, and you put it inside the puppet, and there's a lever on the bottom. As you push the button, it sort of moves the arms and moves the head. So the motion that a puppeteer would have to normally use was not available to this individual. So we transformed this into a motion they could use, which is just pushing the button on the bottom. The relationship with the puppet showplace needs a little bit of work. So we're trying to reconnect with them. They've had some hard times over there. Our contacts there left, but we are hoping to keep that going. We built a bow and arrow aiming system for a blind individual. You may wonder if we had somebody who's actually interested. Yes, we actually had a group of blind people who wanted to be able to aim.
I want to do this.
There we go.
How can I get one?
Yep, it actually worked. I'll show you. Here is on the left, a blind individual holding a bow and arrow with a sighting device that would hone in on a target. The target had some sort of sensor. It would detect where the sensor was. And they developed a whole interface to communicate with the user, whether they should go up or down, left or right. And that was a really interesting part of the process, to kind of figure what that audio interface turned out to be audio, and to figure out. And it actually worked. I don't know if it was actually ever shot, but it could have been. Yeah, absolutely. So let's see if this is going to work. Okay, so this might be. This is a guitar playing device for an individual who wants to play guitar with only one hand. So the strumming is going to be implemented automatically, and then the individual with the impairment would finger the neck of the guitar. So let's see if this works. So we're looking at an individual sitting with a guitar on his lap. Oh, is that it? This is a very short video. Okay, so he's pushing a pedal in front of him. And as he pushes the pedal, the guitar is strumming. If you look closely. He's strumming with his foot. There we go. Yeah, I think we have a better video somewhere. Yeah. Yep. So you can see as he pushes up and down, the strum is sort of going up and down there. All right. We did a series of what's called Go Baby Go. Go Baby Go is a program out of the University of Delaware. A researcher figured out that lots of kids who have mobility impairments, they go around in wheelchairs, or they're moved around, but they're not playing with their peers. So playing, as we know, is a very important part of social development. And his idea was to retrofit these electric cars so that they could control them, these kids could control them, and then they could sort of interact with other kids like in a gymnasium. So here's a short video showing a 5-year-old girl in what looks like a fire truck. And the fire truck has been retrofitted for her to support her back. There's a special seat belt and special controls so she can use it. All right, I think we have time for. Oh, sorry. No, she could probably not. She would be playing with other kids. So typically abled kids would be there. She'd be playing tag or playing soccer and pushing the ball. That's right. That's right. So this program is nationwide. They're building cars. So we basically took the idea and implemented one of them. Actually, we've implemented several, 2 or 3 of them for some kids at SNCC, South Shore Educational Collaborative. We have one more. You can see the quality of our filming has gotten better. So this is a device, Mona, I'm afraid to say, this is one of the canes with electronics in it. So you have to see if you.
No, but is this the RFID reader?
Yes, yes.
I actually think this device has a lot of problems.
Okay, great.
We talked about it. It just needs a lot more. I need to go forward.
So discovering medium range information like office numbers or store hours. So RFID stickers present static information like bathrooms, offices, elevators, and more. So there's a reader. Unfortunately, somehow you're not getting the sound. No. Okay, so what you're missing is that it's picking up information on office doors, on elevators as he walks. Oh, so
I
he-
actually think a device like this would be fantastic at the MFA.
yeah,
Because one of the things that, like, I have difficulty as a blind person in the MFA is finding where all the placards are to
Right.
put in the number for the artwork you're walking on.
yeah, that makes sense. All right, you got the idea. So this one actually works.
The RFID reader.
Yep, that one actually works.
Yeah, it needs some fine tuning,
Great.
but I think this has a lot of problems.
All right. So that's basically it. That's my overview of what enabling engineering is about. It's grown. The simple idea has grown, become incredibly popular. We've had about 800 students have become involved in a project. We've done about, must be 80, 90 projects. Often we're doing 30 at a time. So we found a way to kind of discover, implement, and support a really large number of projects. And the students love it. I mean, you can see. It really, students become very, very passionate about these designs. So thank you for having me. I look forward to hearing more about this group's activities and staying involved. And I'll be happy to come back another time. Yeah. I'm going to run to the train. This is why I'm
Thank you, Professor, for the wonderful presentation you have given us. The interest to join enabling engineering is increasing after this presentation. So we have a short form which you can fill if you want to join enabling engineering. It's a QR. Yeah. I will just the QR code where you can just scan it to join enabling engineering.